Part two, or the back side. We are ready to describe how the following parabolas are transformed when compared to the quadratic parent function, the QPF. QPF. And then we have to remember, what is the quadratic parent function? Well, it's that one that we compare everything to. It's just our basic parabola, which is y equals x squared. So if I graph both of these in the same thing of Desmos, I can describe, like, for example, that they give is narrower, is shifted up 2 units to the left, 3 units. Maybe it's reflected. Or something like that, and so we can talk about that. So y equals x squared is our parent quadratic parent function, and then y equals 5x squared plus 1. So let's take a look at what that looks like. So here's our y equals x squared. That's our red one here, and the green one, the 5x squared plus 1. So so if I take a look, it is more narrow. The 5 tells us it's got to be more narrow. And then plus 1, it is just shifted up 1 compared to the parent function. So really, this one isn't shifted over or anything like that. It is just more narrow. So we can write that. We have more, it's more narrow, or it has a vertical stretch, and shifted up 1 unit. Okay, or just shift it up 1 is fine. All right, so the second one, y equals -4, and then we have x plus 5 quantity squared plus 2. So I know what my vertex is, and so I know it's not at 0, 0. The -4 tells me some stuff. Hopefully I remember some of those things, and maybe I remember them before I even need to look. That would be really cool. So think about that for just a second, or pause here and think about that. But if we look at the graph, the quadratic parent function compared to, so let's look, whoops. Okay, so here's my quadratic parent function. It's in red. This one, our new one, is reflected over the x-axis. Oftentimes we say it's flipped, but really it's reflected over the x-axis. It is more narrow because of the 4 part of that, and then it's shifted to the left 5 and up 2. Wow, so there's a lot of things going on here. So it is more narrow. We can go with that. So it's more narrow, reflected over the x-axis. Oops, axis. In other words, it's flipped. Okay. It was shifted to the left 5 and up 2. Okay. All right, so looking at number 18, I have the 1/2 and I have x minus 6 in parentheses there to be squared, and then minus 5. So there should be some things that I notice. Think about that, what our a value is, maybe what our vertex is, so where it might be located. But let's take a look at what we also graphed, and then that way we can be certain on that. So here's our parent function, y equals x squared. Then we have y equals 1/2 x minus 6 quantity squared minus 5. Well, 1/2 should have told me, oh, it's going to be wider, and it is. And my vertex is way down here at 6, -5, which my HK would have told me that it's at 6, -5. So I went to the right 6 and down 5 when I shifted. I didn't reflect it, but it is wider. So it is wider. This one is. So it is wider because of that 1/2. Shifted to the right 6 units and down 5 units. Okay. Good thing we have Desmos to check ourselves, but hopefully you were seeing some of those things without even checking first. All right, for problems 19 through 26, use the function of f of x equals 4 times the quantity of x minus 3 quantity squared minus 8. So there's all sorts of questions here. These are the same questions we saw, but on the very first part. So what is the vertex? So I should actually be able to look at that and tell that the vertex is my h and k here. And remember, it's minus h, so my vertex should be at 3 and then negative 8. But I'm going to double check. I am going to double check because I just want to make sure, because I have this Desmos tool, and so I might as well double check and make sure I get it correct versus just assuming that I know what I'm talking about. So here's what I have. I have the 4 and I have the x minus 3 in parentheses squared minus 8. So here's my vertex. My tip is at 3, negative 8, and I'm pretty sure that's what we said. 3, negative 8. Yes, all right. Axis of symmetry. Remember that axis of symmetry is going to be that line right here that would break it in half. And so we have x equals that 3. So for our axis of symmetry, we have x equals 3. Notice our vertex is a point, axis of symmetry, we have x equals 3. Roots, zeros, x-intercepts, we should now know these are all three going to be the same thing. Roots are x-intercepts, they are the zeros. They're actually also the solutions. So if I go back to my things here, one of my solutions is 1.586 and the other one is 4.414. 1.586. So we have a solution set of 1.5. Was it 586? Let's double check. Yep, 1.586 and then 4.414. So this is a 586 and 4.414. Okay, my solution set. All of those, zeros, roots, x-intercepts. Domain is how far out does my graph grow in the x part. So we're talking about x, how far out does it grow? Well, can it be stopped, basically? Well, it keeps going on forever because of that part. So we've got the x-center, or the domain, that is going to be all real numbers because it keeps growing. Now my range, it doesn't grow in both directions. It stops. In fact, right here, it cuts off right there, but it keeps going forever in that direction. So y is greater than or equal to, because of this point right here, greater than or equal to that negative 8. So that's going to be my range, is that y is greater than or equal to that negative 8 that goes up from there. What is the standard form of the function? So here's what I have. I have the 4 and then x minus 3 squared, and then we had minus 8 was the other. Yeah. And so if I'm going to put it into standard form, I need to FOIL first. So I'm going to do my x minus 3. I'm going to come over here and just do that, x minus 3, x minus 3. So I have x squared minus the 3x here, minus 3x here, and then positive 9 here. So that means this part right here is just x squared minus 6x and plus 9. And then I can't forget to bring down the 4, and I still have this minus 8 that I need to bring down. So the next part would be to distribute. So I distribute, distribute, distribute. So I have 4x squared minus 24x plus 36, and then I still have this minus 8. So I can put those together and end up with 4x squared minus 24x and plus 28. And remember, this is all y equals. So my answer should end up being that right there in standard form. And you know what? I'm going to graph it just to make sure that I've done it correct. So 4x squared minus 24x plus 28. So I'm right here. So I have 4x squared plus 24x plus 28. Wait a minute. So did I mess up? Oh, it's minus 24x. All right. So minus 24x. Oh, and it is the exact same thing. It laid right on top of there. So we are good to go. All right. So hopefully you are ready for this test. Test is coming soon. You got this. Good luck.